Okay, good morning. So you probably heard I have the flu, and I don't want us to get any further behind than we are. So today we're going to cover 3 videos. The first one is going to be just a big picture video, and then there are going to be 2 example videos. What we are studying today is matched paired t-test. It's also sometimes called a t-test with the dependent samples. Okay, so here we go. Here are the big picture ideas. All right, so we have 2 types of 2 sample tests that we know so far. You have the z-test, where you're comparing 2 samples together, and the important thing here, 2 sample z-test, is that you know sigma 1 and sigma 2. Then the second type of test we've talked about so far is a 2 sample t-test. And here you don't know sigma 1 and sigma 2, you just have your sample standard deviations. Both of these tests rely on an important fact that they are random samples. All of our tests really rely on the fact that we are taking random samples. So what happens if I want to do something like a pre and post test for a group of students? So I give everybody a pretest. And then they get a mean score for this pretest, and so on. And then I give you all a post-test, and you get a mean score for this test. So I want to know, did you guys do better? Did it improve? Did you learn something between the pre and post test? So I can't just do a 2 sample test on this because these aren't random samples. The same people took both tests. And it seems reasonable that people who did well on the pretest would likely also do well on the post-test. So it's not always going to show, if I just take the average of both groups, an actual change in the score. What I want to look at is, I want to look at the differences, the difference. So what you do with the matched pair t-test is you have 2 samples, but they're organized by student or by sample collection, and you look at the difference between the 2 scores. So here is an example. Okay. I want to know something about, do dads have taller dads have taller sons, or those types of things, or I would expect taller dads to have taller sons. So I take the dad's height. Dad, family 1, son. And I take the dad's height. Maybe he's 68 inches, 69 inches, and so on. 65 inches, and 67, so on, so on. Take all of these, right? And this is family 1. Family 2, and so on, right? All the way down. Okay, instead of just saying, oh, what's the average of the dads and the average of the sons, and let's see if they're different, I recognize that these families have genetic traits that are dependent on each other, and that I would expect taller dads to have taller sons. So they're related samples, just like I would expect someone who did better on a pretest to also do better on the post-test. Excuse me. So what you're going to do is look at the differences. So if I take the mean difference over here, and it doesn't matter if you go son minus dad or dad minus son, as long as you're consistent in how you do that and you label them correctly. if you're not consistent or you label them incorrectly, then you're going to be looking at the wrong tail of your test. So you got to make sure that you are very consistent. I'm going to go dad minus son. This is going to be -1, -2, all the way down here. Okay. Now I have this new list of data. It's a single list. Single list of differences. And now we can do a one sample t-test only on the differences. So really, a match pair t-test is a two-sample test that reduces into a one-sample test because you look at only the differences and do that. All right. The next two videos, I'm going to do 2 additional videos. These are quick, I'm sorry. I'm going to do 2 additional videos, each with 1 example on them. And then I'm hoping that you'll be able to do the worksheet that I posted on Canvas. Thanks, and I hope nobody got the flu from me, because it is miserable.